So one of the most important things that we do in chemistry is we spend a lot of time converting between one unit and another unit, and that's for a variety of reasons. Sometimes we start off with a chemical in one particular unit, we need to get it into another unit in order to utilize it in a lab experiment. Or let's say that you're working in the nursing field and you're given this amount of medication and it needs to be converted into something else, or you need to figure out how much of that medication to give to an individual. This is how we use things called conversion factors, and they're used to convert between different units. So if I asked you how many minutes there are in 3 hours, you would hopefully be able to tell me that that would be 180. And the reason you know that is that there's 60 minutes in every 1 hour. We just simply take 3 times 60 and multiply it together. Now, it'd be nice if all conversions were just that simple. Unfortunately, they're not. That's why we end up utilizing a variety of conversion factors in a process called dimensional analysis, which we'll talk about here in a moment. But conversion factors are fractions with different units on the top and bottom that represent the same quantity. So for example, 12 inches in a foot, 3 feet in a yard, 4 quarts in a gallon, 16 ounces in a pound. In any of those mathematical expressions, the first part before the equal sign is the same distance or the same amount as after the equal sign. 12 inches is equal to 1 foot. That's the same distance, it's just in 2 different units. 3 feet into 1 yard, again, same distance, just different units. One thing we also need to make sure that we consider are the metric conversions that we've talked about previously. You have a handy little chart there that tells you all the different metric conversions. Notice that when we do these metric conversions, the number 1 always goes with the prefixed unit, and whatever power of 10 we're looking at goes with the unprefixed unit. That will save you a lot of time and a lot of effort when we go through and do this. And notice that on the right-hand side here, I've gone through and written a conversion factor for milliliters to liters. Again, notice that 1 is going with the prefixed unit, and then whatever power of 10 is listed in that chart goes with the unprefixed unit. Whatever's on top and whatever's on the bottom is going to differ depending upon what you're converting. So it's very, very important to make sure that your math skills are up to par when we do things like dimensional analysis. This is one of the most important things that you're going to learn in this course is that process. So again, go back and take a look at these prefixes here. You can utilize the exponential number that's listed there, or you can just simply type out the number in standard notation. That's perfectly fine. But notice here, 1 is always going to go with the prefixed unit. And then off to the side here, we're going to utilize this, where it says mathematical meaning, we're going to utilize those numbers in the non-prefixed unit to help us understand how we convert between different materials. Remember that these prefixes can be used for any metric unit. That includes meters, grams, liters, and other metric units that you may encounter. We'll primarily use grams, liters, and meters in this class. Also notice the ones that are in pink. These are the ones that you need to memorize because these are the ones that are the most important and the ones that we use most frequently in a chemistry class. If we break it down even further, the 3 that we use most commonly are kilo, centi, and milli. So making sure that you have those memorized is going to be very important for you to move forward. Remember that the number 1 always goes with the prefixed unit, and then whatever the base unit is, the number that is on the right-hand side of this chart is going to go with the non-prefixed unit. And there are a variety of different conversion factors that are out there that you can utilize to convert between different materials. So take a look at the inch to centimeters one on the top of the chart listed. 1 inch is 2.54 centimeters. You can write that 2 different ways depending upon what you're trying to do with it. You can put 1 inch on top and 2.54 centimeters on the bottom, or you can flip it. Again, that's going to be dependent upon where we're starting and where we're going. I'll show you how to utilize these conversion factors and more importantly, how you know which unit goes on top or on the bottom of which individual step here in just a moment. But notice that any equivalent value can be utilized as a conversion factor one of 2 ways. We can take the number on top and the number on the bottom and we can switch them depending upon what we're trying to convert from and what we're trying to convert to. And again, this is just a quick little review of the information that we've just talked about in terms of the relationships between different materials. Again, when we're trying to look at conversion factors, we're looking at 2 different units that represent the same quantity. So example, 1 minute, 60 seconds. 12 inches in a foot, 4 quarts in a gallon. It's the exact same amount. However, it is listed as 2 separate units. Make sure you understand how those metric prefixes work as well. So this is one of the most important things that you're going to need to understand for this class. This is important to understand this as a process. This is not something that you just go through and memorize. You have to understand the individual steps that are required in order to convert between different materials and different units. So this is a big part of chemistry. And a lot of this is recognizing what in a problem is known, that is the information that is given, and the information that is unknown, that is the quantity that we are trying to go through and solve for. So I have a question up here in the top right. It says a standard aspirin tablet contains 325 milligrams of aspirin. How many grams of aspirin are there in a standard tablet? So the first thing that we need to do here is find our known and then be able to find our unknown from that. And the known is 325 milligrams of aspirin. And our unknown is how much that quantity is in grams. So the first step with any of this is to identify what is given, your known, and what the question's asking for, which is your unknown. If you do this for word problems, it's going to save you a ton of time as you work through some of these styles of problems. Step 2 is write out your known amount on the top of a fraction. I'll refer to that as the numerator from now on. So notice that all I did in that step is I took 325 milligrams and I put it on top of a fraction. Remember that conversion factors are all fraction based. We're going to have one unit on top of one step and another unit on the bottom of the same step. Both of those will be equivalent values of one another. Step 3 is super important. Whatever unit you used at the top of the previous step goes on the bottom of the next step. As we go through and do dimensional analysis, it's very important that our units cancel each other as we work through the step-by-step process of dimensional analysis. So whatever unit is on top of the previous step always goes on the bottom of the next step. And in step 4, consider what we are trying to get in terms of a unit and determine if there's a single conversion factor that will get your final unit on top of the last step. And in this case, this is true. We have a conversion factor between grams and milligrams. That is something that we've established in this chart previously, right? If I look here, I can say that 1 milligram, remember that 1 always goes with the prefixed unit, is equal to that of 0.001 grams. So I utilize that as a conversion factor in the subsequent steps. So notice here, we find a direct numerical conversion between your known and unknown values and plug those numbers into the fraction. So again, notice what I've done with the numbers here. I took 1 and put it on the very bottom for milligram, and then I took its equivalent on the right-hand side of that chart times 10 to the negative third, or 0.001, and put it on top of that step with grams. Now again, those are equivalent values of one another. They are the same mass, they're just in 2 separate units. Now what we want to notice is that the units cancel each other. Whatever's on top of the previous step goes on the bottom of the next step. That means that those milligrams will cancel each other. Anything divided by itself will cancel itself. So what we end up with is grams left at the very end of the last step. You want to continue to do this until you have your desired unit left. And you may need multiple steps in order to achieve this. Now we just simply do the math. We're going to take 324, multiply it by 10 to the negative third, and then we're going to divide by 1. So multiply across the top and divide by what is on the bottom. The significant figures you use to round for your answer is the same as what you start with. So I do notice that it says 325 and 324, but the process is exactly the same. Follow it step by step. So what we end up with here, and it doesn't show it, but it should be 0.324 or 0.325 grams when you're done, okay? So making sure that we go through and follow this step by step, one step at a time, will lead us and ensure that we utilize the proper dimensions when we go through and do math with dimensional analysis. This is something you have to practice over and over and over again. You have to be able to do the dimensional analysis. You can't just do the math in your head or punch it into your calculator. I have to see that you can do the step by step dimensional analysis that's required for this. Now, there are a handful of problems that are on here. You're more than welcome to try any of these you want, and I'll go over them here in just a couple of moments. Stay tuned. So things are a little bit different here just because the way that the iPad works. My handwriting's also been described as atrocious, so I do apologize for that in advance. But let's see what we can do here. So we're going to start off with 34.6 centimeters, and it asks us to convert that to meters. So we have our unknown, which is meters, and our known, which is centimeters. So start just like what we talked about. Take the information given you in the problem, so 34.6 centimeters, and put it over a fraction, just like what I've done here. Remember, whatever unit is on top of the first step goes on the bottom of the next step. And it's asking us to go from centimeters to meters. So what I want us to do is take a look at our chart. And we do have a conversion between centimeters and meters. Remember, those prefixes can apply to any of the base units that we've talked about before. So I can go from centimeters to meters. Remember that 1 goes with the derived unit, and then whatever it says on that right-hand column is going to go in the opposite part of the dimension. So I go through and I just put that in right there. So that's my dimension. 1 centimeter is 0.01 meters, just like what we've gone through and discussed. Okay, so I double check my work. I make sure that my units cancel. So centimeters cancel, centimeters cancel. I'm left with the unit I desire, which is meters. I plug that into my calculator and solve, and what I end up with is 0.346 meters. Again, notice that I keep the same number of significant figures. So there's 3 sig figs over here, and there's 3 sig figs over here. So making sure that you go through and take it one step at a time. Just think about what we've talked about. Think about how these individual steps work, and you'll do just fine with this. Let's continue on with this next problem here. It says 1.68 meters to kilometers. Again, identify what you're starting with and where you're ending, and start with the information given you in the problem. So 1.658 meters. Put that on top of your fraction. Whatever unit is on top of the first step goes on the bottom of the next step, so meters. I go and look at my chart. I find that there is a direct conversion between kilometers and meters. Remember that 1 always goes with the unit with the prefix, and then I look at my chart. I find that there's 1,000 meters in a kilometer. Okay? Or you could say 10 to the third, perfectly fine. I tend to prefer to utilize these types of numbers. It's just my own personal preference, but if you go through and you end up utilizing those exponential numbers, perfectly fine. Just make sure you type them into your calculator correctly. Okay, my meters cancel. I'm left with kilometers on the last step. Whatever I get, I'm going to have 4 significant figures. Again, it's the same as what we start with, so 4 sig figs over here. I need 4 significant figures in my answer. So we divide that out, and what we end up with is 0.00165 kilometers. Again, retaining the same number of significant figures from when we started with on the left-hand side here. Next problem says centimeters to millimeters. So again, start with the information that's given to you in the problem. So 0.389 centimeters. Whatever unit is on top of the first step goes on the bottom of the next step. Now, if I look at my chart, I do not have a direct conversion between centimeters and millimeters. I can go from centimeters to meters, though, again, based on the information in the chart. 1 centimeter, again, 1 goes with the prefixed unit, 0.01 meters. Now, what you notice here is that I am not done with my problem. The unit I have on top of the last step is not millimeters. If that is the case, you need to repeat the process again, utilizing conversion factors until you get to the correct answer. Again, it takes time and practice to recognize this, but the more you do this, the better off you're going to end up being. We follow the same steps though. Whatever unit's on top of the previous step goes on the bottom of the next step. I do know that there is a conversion between meters and millimeters because I can utilize my chart. 1 millimeter is 0.001 meters. So 0.389 centimeters, when I go through and I plug all of this into my calculator, I go through and do my math, I end up finding that I have 3.89 millimeters. And again, we retain the same number of significant figures that we started with in the problem. Last question here, 91.23 meters to millimeters. We're going to do the exact same thing again. Here's where we start. Here's where we're going. 91.23 meters. Whatever unit's on top of the previous step goes on the bottom of the next step. So meters, I can go meters to millimeters. Utilize the conversion chart there. 1 always goes with the base, 1 always goes with the derived unit, the unit with the prefix. 0.001. Again, that's all based on the chart. You end up with 91,000. You end up with 91,230 millimeters. Again, retaining the same number of significant figures I did when I started my problem. So again, take your time with this. This requires a lot of practice, and we're going to spend some time practicing with it during recitation, as well as a couple of in-class practice problems as well. Let's take a look at another example. I'll give you a minute or two to look this over, think about how you would go through and solve for this. You have a little bit more of a complex problem here, help you out. Again, think about what is given and what is unknown in this problem. The only numerical value we're given is 1.00 millimeters, and it wants to know the length in inches. You are going to need multiple conversion factors in order to be able to solve for this, okay? There may be more than one right way to do it. See what you can do. Work through some of those practice problems, work through a few of those conversion factors, and see what you come up with. We'll be right back here in just a moment. So once again, there are multiple ways to go through and solve this problem. I don't have a conversion factor sheet in front of me at the moment, but I do know of one way I can go through and do this. Again, start with what's known here. So 1.00 millimeters. Our unknown is in inches. That's what we're trying to get this converted to. Bottom of the next step, millimeters. I can knowingly convert millimeters to meters based off of our metric chart. One goes with the prefixed unit. We use the number on the right-hand side, so 0.001 meters here. I'm not done. Again, I got to get to inches. Meters on the bottom. This time I'm going to go to centimeters because I know the conversion factor between centimeters and inches. Any conversion factor that is a non-metric one that I didn't discuss previously, I will give you. So you just need to make sure that you know how to utilize them. You don't have to go through and memorize them all. It does help to have some of them memorized because it does make this process a little bit easier. Same thing, our next conversion factor, take the unit on the previous step, put it on the bottom of the next step. Now to go from centimeters to inches, we just use one of our English to metric conversion factors. Double check to make sure that, again, all of your units cancel and the unit you want is on top of the last step. We're looking for inches. I have inches on the top of my last step. Millimeters will cancel, meters will cancel, centimeters cancel. So now all I need to do is plug that into my calculator and solve and round to 3 significant figures. So what I end up with here when I'm done is 0.03937 inches. Remember, we want to round to 3 significant figures here. So that first 0, remember that does not count. So 1, 2, 3. That's going to round up as opposed to down. So 0.0394 inches is your answer here. Okay? So again, it's all about practicing this, taking the time, realizing what you have, where you're going, and then working through the dimensional analysis in order to be able to solve for it. I'm going to go back to regular mode here in just a moment, but again, take some time, take some time to practice, some time to work through this, and you will do just fine. This is one of those, again, key skills you need to make sure that you learn so that you're successful in this chemistry class. So just a couple of final notes regarding dimensional analysis. This is something that you have to practice a lot. This is one of, if not the most important mathematical practice you are going to use in this course or any other chemistry course that you need. Always check to make sure your units cancel before you do any math, and make sure that the desired unit is on the last step, on top of the last step of your dimensional analysis work. The unit on top of the previous step goes on the bottom of the subsequent step every time in this class. Are there instances where that is not the case? Yes, but for our class, for simplicity purposes, that is always going to be the case. You'll be given a list of general conversion factors, but the metric units need to be memorized. You need to make sure you know how many milligrams are in a gram. You need to know how many kiloliters are in a liter. Remember that those metric conversions can be used for any metric-based unit. The only 3 we're going to look at in this class include gram, liter, and meter.